So y'all, we are going to be talking about a few different integer and rational exponent rules today. All right, guys? So the first thing that we are going to be discussing today is zero exponents. All right, guys? And what do we do with zero exponents? Well, guys, there's a couple rules that we have for zero exponents. All right? Or actually, there's really just one. All right, guys? And how we can write this out, the rule for this is that a to the 0 power is equal to 1. And guys, really, anything to the 0 power is equal to 1. And to prove this, I want you guys to do this in your calculator. Pick, here, we'll start with one number. So let's see here. If we start with 4 to the 0 power, what is that going to be? Why don't y'all type that in your calculator? Hopefully, if you guys follow the rule, you'll be able to see it. 4 to the 0 power is equal to 1. All right, guys? Anything to the 0 power is equal to 1. So, that being said, I want to look at this. Let's do a second example here. So, and I'm going to kind of I'm going to show you guys, if we have x to the 0 power, what is that going to be equal to, y'all? 1. Because anything to the 0 power is equal to 1. It's that simple. We just have to remember that anything to the 0 power is equal to 1. Now, I want to talk to you guys kind of like why this is true. So I want you guys to think about this. Let's say if I have x squared over x squared. Well, what's that going to be? X squared over x squared is going to reduce down to 1, because anything over itself is just 1, right, y'all? Cancels out. Well, guys, if we follow our quotient rule, what do we do to exponents when we divide our powers here? We subtract. And guys, what's 2 minus 2? X to the 0, which is 1. So guys, this kind of helps us see the reason why anything to the 0 power is equal to 1, because anything over itself is 1. So if we follow those quotient power rules, 2 minus 2 is 0. So it proves itself there that it's going to be equal to 1. All right? So then I want to do a couple more examples here. All right? So let's look at number 3 here. So our example for number 3 is going to be negative 3abc. All of that is in parentheses, and we're going to raise it to the 0 power. And what's that going to be, y'all? 1. Exactly. We're not doing rocket science here. Anything to the 0 power is equal to 1. All right? And then I'm going to go here. We're going to do number 4. And I'm going to say 5x to the 0 power. Well, guys, what is this going to be equal to? Well, is the 0 being applied to the x? I mean, the 0 is being applied to the x. Is the 0 being applied to the 5? No. So this is like 5 times 1, right? Because our x to the 0 is 1, but our 5, that's just the coefficient. So 5 times 1 is equal to 5. Do y'all feel good about that? So only what's being raised to the exponent of 0 is equal to 1. And then one last little example here I will do for you guys. Let's see here. We're going to do negative 3 x squared y to the 0 power. So guys, what is this going to be equal to here? Guys, remember this 5 was our coefficient, which is why we didn't raise it to the 0 power. So do I raise this negative 3 to the 0 power, y'all? No. This negative 3 just stays here. But this whole thing x squared y raised to the 0 power, this entire thing inside the parentheses is going to turn into 1. So my final answer is -3. Y'all feel good? So the rule is, if anything's raised to the 0 power, it's just equal to 1. Okay? So that's our first thing that we're covering today. Anybody have any questions for me over that? Anything to the 0 power is just equal to 1. All right. So, what did you say? Will, you have any questions? Oh, sorry. Okay. So then we go here. And now, guys, I want you guys to talk. We are going to talk about negative exponents. Okay? So negative exponents. So we talked about 0 exponents. Now we're going to talk about negative exponents. And guys, here's the deal. We only want positive exponents in our answer. So we only want positive exponents in our answer. Okay? So, oh man. So we only want positive exponents in our answer. So the rule that we have for this, guys, is, I'm going to show this to you guys. So it's a to the negative m is equal to 1 over a to the positive m. And another way that we can write this, we can kind of write this two ways. 1 over a to the negative m is equal to a to the positive m. Okay, guys? It could turn us into decimals here. All right? But we want to keep it as a fraction. So, guys, what I want to tell you guys, we have two little rules right here. Okay? We change the position of the base. So if it was in the numerator, it's going to jump down to the denominator. And then we change the sign of the exponent. All right, guys? So if it was a negative, it becomes a positive. Here, we had a negative exponent. We wanted to change that, so we changed the position of the base, and then we changed the sign of the exponent there. So these are our two little rules that we follow here. So we change the position of the base, and we change the sign of the exponent. So those are the two things we do. Okay, we change the position of our base, and we change the sign of our exponent. Now, when I think about this, guys, you can say, okay, if it was in the numerator, it's going to go to the denominator. All right? And if it was in the denominator, it's going to move up to the numerator. Now, I actually like to think of this like a little elevator button, all right? Where if you push the button, beep, it changes floors and it moves to the bottom. Here, if you push the button, boop, it changes floors and it moves to the top. So whenever you get rid of your negative exponent by pushing that little button, it changes floors. So if it was on the top floor, it moves to the bottom floor. If it was on the bottom floor, it moves to the top floor. Y'all okay with that? All right. So I'm going to do a couple of little examples here for you. All right. So let's look. I'm going to write number 1. I'm going to go over here and write a number 2. And then I'm going to give myself a few spots here. 3 and a 4. We're only going to do a few examples. All right. For you guys as you're checking this out. So if we have 7 to the negative 1 power. Well, guys, this is really like 7 to the negative 1 over 1. Are you guys comfortable with that? So if we want to change this into a positive exponent, we change the position of the base. So the 7's going to move to the bottom here, and it's going to become positive. So you think, okay, we got to move it down. Now, what did it leave behind? It just left behind a 1. So this is 1 over 7 to the first power which is really just the same thing as 1 over 7. You guys comfortable with that? 1 over 7 to the first power is the same thing as 1 over 7. All right, we're going to do another examples, and we're going to throw some variables in here this time, okay? So our variables are going to be, let's see here, 5a cubed b to the negative 5th. All right, guys, and we're going to pretend like this is, or not pretend, it's all over this understood one right here. So, guys, for my 5, does this need to change right here? Does the 5 need to change? No, the 5 is still just a positive exponent, because remember, it like has a little exponent of 1 right there. So the 5 stays up top. Does my a value, does my a variable, does that need to change positions? No, that's a positive exponent, so it doesn't have to change. All right? But my b variable here, this guy has a negative exponent, so it needs to change. So this is going to become b, the b to the 5th is now in the denominator. So what we have is we have 5a cubed over b to the 5th. Are you guys comfortable with that? So all we're doing is if it's a negative exponent, it just changes floors. All right? Goes from the numerator to the denominator or the denominator to the numerator. All right, let's take a look at another one here. All right, we have negative 8x to the negative 4th y squared over y to the negative 3. All right, guys? So let's take a look at this here. So does my negative 8 need to change floors, so to speak? I know it sounds kind of weird. Does my negative 8 need to change floors? No, it doesn't need to move anywhere. So this negative 8 is going to stay up here. Because does it have a negative exponent? No, it has a little positive exponent. Okay? Then, does my x need to change floors here? It certainly does, because it has a negative exponent. So this x is going to move down here to the bottom. Are you guys comfortable with that? All right. What about this y squared up here? Whoops, sorry. Does this need to change floors? Is that a positive 2? Yeah, so we're just going to leave it up here on the top. And then the last one here, my y to the negative 3, does this one need to change floors? It sure does, because it's a negative exponent. So it's also going to move up top. Are you guys comfortable with that? So now we've rewritten it as negative 8 y squared y cubed over x to the 4th. Can we simplify this? Can we simplify that, y'all? We certainly can. This is going to be negative 8. And what are we going to do to our y's? Y squared and y cubed is going to become y to the 5th. And my x to the 4th is just remains down here in the denominator, because we don't have to simplify anything else. So this right here is how we simplify those guys. Do y'all feel good about that? Ish? How do we feel? Thumbs up, middle, thumbs down. We're feeling okay? All right. Last one here, okay? We have we're going to do parentheses, negative 3x to the 4th raised up to the negative 5th power. All right, guys. So we can do this a few different ways. We can move this entire thing to the denominator and then distribute our powers, or we can distribute our powers and then move them. I recommend, for this particular one, moving it first. So this entire thing will move down to the bottom, negative 3x to the 4th, because it's all being raised to the negative 5th power. So now it's all going to be raised to the positive 5th power. Do y'all feel good about that? And we just left behind a little 1 on top here. And now we just have to follow our power rules, don't we? So the 1 still stays up there. And then we go here, and we say, okay, negative 3 raised to the 5th power is going to be what? What is negative 3 raised to the 5th power? I believe it's a negative. Negative 243. So how we do that, guys, if you're struggling with that, you just do negative 3 raised to the 5th power. And that gave us negative 243. And then we have x, 4 times 5 there. That's going to be x to the 20th power. Are you guys comfortable with that? And this right here is our little simplified version. Cool? Now, you guys, we also could have multiplied it in at the very beginning, where if we had negative 3x to the 4th raised to the negative 5th, you also could have just gone here and multiplied that in and gotten negative 3 to the negative 5th power times x to the negative 20th power, right? So you could have multiplied those guys in, all right? And then you would have had to change the positions of those base. You would have had to change the floor, so to speak, all right? So negative 3 to the positive 5th power, you still would have ended up with negative 243 on the bottom. And then when we changed this guy and moved it down, it still would have been x to the 20th power. So we still would have ended with the same things. It just depends on if you wanted to multiply at the beginning or multiply at the end. Does that make sense, y'all? Do y'all feel okay with that? So it kind of just depends on how you'd want to do that, because both of these guys had those negative exponents that would have needed to move down. All right, y'all, so both of those would have needed to move. Okay, so now we're going to go to our last little set of stuff here, and then we're going to be done. All right, so these are all negative exponents. So now what we're going to do is we are going to be talking about rational exponents. All right, rational exponents. Okay? So let's take a look at these. Ooh, I like to use some pretty colors on this one. All right. So up here at the top, we are going to be talking about rational exponents. Okay? So these rational exponents, all this means, guys, is these are exponents with fractions. Okay? So these are just exponents with fractions. All right? So what we have here is, guys, if you have an exponent or a rational exponent, it is going to look similar to this, where you have a to the m divided by n. All right, guys? So basically, your exponent is going to have a fraction. So these are also called fractional exponents. And what we are going to do, guys, is we are going to be able to rewrite this rational exponent as a radical. All right? We're going to rewrite it in radical form. So how we're going to rewrite this, guys, is this is going to be rewritten where our base is still the base. The numerator is going to become our exponent, or our power here. And then the denominator is going to become your root. All right, guys? So I'm going to actually write those things out here. All right? So my a represents the base. And when we go to radical form, it's still the base. The base is your base. All right, guys? The m, when we're in rational exponent form, that represents your numerator. And when we go to our radical form, this represents our exponent. Or sometimes we like to say the power. All right, guys? And then the n here, this is going to be your denominator. And that will become the root of your exponent. Of your radical. That's going to become the root of your radical. Are you guys comfortable with that? So the denominator is going to become your root. Oh man, I'm kind of running out of ink here. Okay, so that denominator becomes your root. All right, so now what we are going to do is we are going to practice rewriting these with the different values here. I think I'm going to have to change pens because my blue pen is almost out here. Okay, so the denominator becomes your root. All right. So what we're going to do is we are going to write these, and we're going to do some few examples, and we are going to transfer from rational exponent form to radical form. All right? And one way that you can always think about this is you got to think, okay, it's the exponent over the root. It's the exponent over the root. It's the exponent over the root. All right? So here we go. So I'm going to give us, let's see here. I'm going to do number 1. I'm going to say 8 to the 1/3 power. All right? Number 2 is going to be 27 to the 2/5 power. Give myself a little space here. 3 is going to be 2xy squared to the 3/4 power. And 4 is going to be 3a to the 4th to the 1/5 power. All right, guys? So we're going to take a look at some of these guys here. All right? And we are going to rearrange these. So guys, if we want to rewrite our rational exponents in radical form, well, I like to go ahead and write my little radical because I know I'm going to need a radical. Now, what is my base for number 1 there, Adrian? 8. So that's still going to be my base inside of my radical. All right? And then what is my exponent going to be right there? Let's see here. Miss Sophia, what's my exponent going to be? It's always going to be the numerator, right? So what's my exponent going to be for my 8? Just 1. Yes. And then what is the root going to be? Let's jump back to Miss Abby. What's my root going to be? 3. So we have our 3 on the outside here. So guys, it's just the cube root of 8 to the 1st power, which we could actually rewrite. Do we really need the 8 to the 1st power? No. So we could rewrite this as just the cube root of 8. Are y'all comfortable with that? And actually, y'all, the cube root of 8 is an even number. All right, guys? Do y'all know how to find the cube roots on a calculator or any kind of root like that? All right, guys, if you turn on your calculator and you hit math and you jump down to this 5th one right here, you can type whatever you want in for your radical. So I'm going to say 3. The cube root of 8 is going to be 2. So this is the cube root of 8, but it can actually simplify down into just 2. Are you guys comfortable with that? Most of the time it would be like some nasty decimal. I'll show y'all on number 2. Okay? So now we got 27 is equal to the 2/5. So what is my base going to be, Emiliano? Ooh, for number 2? 27. Excellent. Okay? And then what is my exponent going to be, Miss Eva? What's my exponent going to be? 2, yes. All right, so we're just going to rewrite it. And then what is my root going to be? It's the denominator. So that's just 5. So it's the 5th root of 27 squared. Now, guys, if I do this in my calculator here, the 5th root of 27 squared, does that give me a nice even number? No. Most of the time, these are not going to be nice even numbers. All right, guys? So this right here would be our final answer. Do y'all feel good about that? Because it's equal to some really weird decimal. So you want to go ahead and rewrite it in that rational exponent form. All right, y'all? So that's how we want it to be written. All right? Now let's take a look at number 3 here. All right? We're going to rewrite these in our rational exponent form. So, in our radical form. We got our rational exponent. We want to rewrite it in in our radical form. All right? So Maria, what's my base? 2xy squared. The entire thing is the base, right? Because that entire thing is being raised to this exponent. And we want to go ahead and put that in parentheses so that we don't lose that. That 2xy squared, the entire thing is my base. And now what is my exponent? What is it going to be raised to? 3, because that's the numerator. And then what is the root? 4. So it becomes the 4th root of 2xy squared raised to the 3rd power. All right, so this is our final answer right here. So all we're doing, guys, is just rearranging. Now, I do want to tell you, this one could actually be written a couple ways. And so I just want you guys to be aware of this. You could write this one as 2xy, the 4th root of 2xy squared, and then you could raise the entire thing to the 3rd power as well. These both are those represent the exact same thing. We can raise it all to the 3rd power, or you can just do it underneath the radical. Do y'all feel good about that? It can be either way. Those are the same thing. All right, then let's take a look at number 4 here. Number 4, what is my base going to be for number 4, y'all? What is the base for this right here? 3a to the 4th, the whole thing. A good hint is if there's parentheses in one, there's probably going to be parentheses in the other. So 3a to the 4th, and then what is my exponent going to be? Just a 1, and then my root is going to be a 5. Now, once again, we don't really need that 1 root. We don't have to have it there because it's an understood 1. So you could write the answer to this one also as the 5th root of 3a to the 4th. So you could drop that 1, and then you wouldn't have to have those parentheses. All right? So this one can also be written 2 ways. All right? I want you guys to see that those are the exact same thing. All right. So this is if we're going from rational exponents to radical form. Now, guys, we're going to go the other direction. So we are going to rewrite the radical as a rational exponent. So we're going to go the opposite direction here. We're going to rewrite the radical as a rational exponent. All right, so I'm going to keep going here. So we have 5. So I'm going to write this as the cube root of x to the 9th. 6 is going to be, let's see here, I'm going to do the 5th root of x to the 8th. And then let's see here, number 7. I'm going to do just the square root of 2 to the 3rd. And number 8 here, we are going to do the 4th root of 2xy cubed. All right, guys, are y'all comfortable with these? Now we want to rewrite the radical as a rational exponent. So we're going to go the other direction now. So, guys, what we want to do is we want to recognize our base. So what's my base, y'all? It's just x. So this one we're going to rewrite as x. Okay? And then what is the top number going to be? What is my numerator going to be? The exponent. So that's going to be my numerator, and then my denominator is going to be that root. Now, guys, could we simplify this potentially? What's 9 divided by 3? Anybody? 3. So this would actually, you could actually rewrite this guy as x to the 3rd. Do you see that? Because 9 divided by 3, let's simplify it. It's 3. All right? Now, let's do number 6 here. Alrighty, so who do we have back there? Miss Andrea, what is our base going to be? Yep. And then what is my exponent going, the numerator of my exponent? Ooh, okay. So the exponent inside here, this power is always going to be on the top here. And the root is always going to be the denominator. So it's x to the 8/5. Do you see that? So you think like, okay, inside over the outside, all right? It's the power over the root. Power over the root. The exponent over the root. All right, so now let's take a look at this one here. So what is my base for number 7? 2. All right, what is the numerator of my exponent going to be? 3. And then, y'all, what is the root here? What is this root? Do we have anything right there? Now, guys, this is, what do we call this symbol right here? It's a square root. So what do you think this understood number is going to be right here? It's actually going to be a 2. Because if there is no number on the outside of a square root, it is understood to be a 2. I think this is like the only time that the understood number is 2 instead of 1, right? So this is one of the only times that understood number is a 2 instead of a 1. So you guys can kind of write this here. So guys, if there is no number on the outside of a square root, comma, it is 2. All right, guys, because it's a square root. Up here we were taking the cube root. This was the 5th root. This will be the 4th root. So this square root, we understand it to be 2. All right, last one here, guys. So what is my base for this problem right here? What is my base for number 8 here? Anybody want to help me? What's my base for number 8, y'all? It's 2xy cubed. Guys, the base is actually this entire thing, 2xy cubed. Because this cube is only relating to the y. It's not relating to the other stuff. So y'all, the power that this entire thing is being raised to is to the first power. So this right here, our numerator is 1. And then what's my denominator going to be? 4. So guys, this right here could be written as 2xy cubed raised to the 1/4. And this actually mirrors our number 4 from up here. When we raised it to the 1, when this 3a to the 4th to the 1/5, you could have written it with the 1 or without the 1. So this one was given to us without the 1, but then we could have written that 1 in there. All right? So this entire 2xy cubed was all raised to the first power. All right, guys. So that's all that I have for you guys today. So what you guys can do is you guys can go ahead and get started on your homework.